So we're doing the area between two curves and finding what the area between the two curves is. And so let's go through a few examples. So here we have the setup, and it's a definite integral that gives it says not to solve for it, but we're going to solve for it on here. So we're given two equations. One is a quadratic, and then one is just a constant function at 0. So if I look at that and we graph it, it would look like this. Here is the graph, which is y equals to 0, the horizontal line, the constant function, and here is your parabola. So the main thing you need to know if you're finding the area between two curves is where do these two curves actually intersect? And it's found here that it's intersecting at x is equal to 0, so that's one intersection point, and then the other intersection point is 2. So we want to find the area between these two curves, which is the brown shaded area right there, and it's going to be between the constant function g of x and the quadratic f of x. And then when you do that, it's only going to happen not for the whole entire time, but just between 0 and 2. So when we set up the integral, this is what it's going to look like. It's going to look like from 0 to 2, because that's where we want to go. We're going from 0 to 2. So this is going from 0 to 2. And so instead of making an indefinite integral where you would have to add a plus c, we're just finding that specific area. So it's from 0 to 2. And then what are we going to do to these functions? Well, we want to find the difference between these two functions. So we're going to take one and subtract it from the other one. The one on top, usually the general rule is the one on top is the one we're going to subtract the one from the below is. But you should always take in consideration what exactly it is that you're finding. So here we take the constant function, which is 0, and we're going to subtract it times f of x, which is the x squared minus 2x, the quadratic. So we're taking 0 minus this function right there. And so then what happens here is that 0, you're still going to get that negative. In integrals, if there is a negative, it's the same as a constant. Not the same as a constant, it's the same as a coefficient. So we know with the coefficients, we actually pull it out, and that's what it looks like. So that's like the -1 coefficient of the function. So we pull it out, we take the integral the way we normally do. And so this is just saying that we're going to get the opposite of the area on here. So we know it's below the x-axis. So normally this is supposed to be a negative area since it's below the x-axis. But because we have the negative in front of it, this area is going to be negative. That area is, this is going to be negative. So we're going to end up getting a positive area at the end when we solve for it. So let's go ahead and do that. Let's solve for it here. And so we have this here is the equation that we had there. And so we need to do the antiderivative for this, find the integral. And so the way that you do it is you keep that negative there. And then you're going to do the antiderivative, which is going to be x cubed over 3 minus, and then it's going to be 2x squared over 2, and that's going to cancel out. And so this here is going to be my antiderivative. The negative belongs to both of them. And so we're going to evaluate it from 0 to 2. And then what you do now is you're just doing the evaluation. So you start with the top number here, and then you evaluate this minus the lower number because this is the bigger number on there. Remember, if we're going, we're doing the exact same thing that we're finding the area between 0 and 2. So this one here is the bigger one on there. Okay, so looking on this area here, we are going to put in the negative, and then we do 2 cubed over 3 minus 2 squared. And this is going to be parentheses, parentheses, minus parentheses, and then we do it again, 0 cubed over 3 minus 2 times, well, I guess we don't need that 2 there, right? So we don't need the whole thing here, but we'll just do it. And so what happens is that this goes to 0, and so we only have to worry about this part right there. And so we end up with negative 8 over 3 minus 4. And in order to add these fractions, what you're going to do is you are going to multiply this by 3 over 3. And so we get 8 over 3, 12 over 3. And your answer there is going to be negative. It's a negative inside a negative 4/3. And so it becomes positive 4/3 units. And that's the area in between the curves, and that's how you solve for it. So let's go through another example. Here's another one. And so now if we have this, we have two quadratics, and what you're doing here is one of them is concave down and one is concave up because the leading coefficient shows that. And so we want to find the area of the shaded region here. And so we need to find the intersection. And so the intersection is going to be at 0 to 3. So that's what's going to give us the integral from 0 to 3. And this is equation g of x. So our g of x is the one that's concave down minus the one that's below, which is the one that's concave up. And then you find the easiest way is not to take the integral of this, is to actually combine like terms like it's done right here. So this is combining like terms here. And then you take the antiderivative of this, and then you evaluate it between 0 and 3. And so you substitute that in there, and you get this to be 9 units. And that's how you solve that one. And then let's look at this one right here. This is the sine function. And so if we know, again, we're doing the function that is going to be 0 here. Y is equal to 0. That's your g of x. And then the sine function, it's the negative sine function. So instead of going up, it actually goes down. And so we want to find the area in between those two curves. So the area is below the x-axis here and above the x-axis here because that's where it's caught. And so now in this case here, we have, we are going to look at when it's 0, theta is going to be at negative pi, at 0, and at pi. So we need to divide, the solution to this is that we need to divide the graph into two separate integrals. So we're going to do two separate integrals here. So we're going to do it from negative pi to 0 and from 0 to pi. And so that's what this is stating here. So we're looking at this integral here individually and then that one as well. So here is the two integrals that we have here. We're going to do from negative pi to 0, the negative sign minus 0. Notice how sign is above and 0 is below. So it's negative sign minus 0. And in this case here, it's this one here is above, so that's 0 minus this one right there, and it's between 0 and pi. So you are going to take the integral of that by doing what we know the rules of trig. And so we know that this one here, when you take this derivative, it's going to be cosine. And so from negative pi to 0, and this one is negative cosine on there. The reason why this one changes a negative and negative became a positive, so that's why going backwards, it's going to be a negative cosine there, and it's from 0 to pi. And so then you just evaluate it. The answer then is going to be 4 units. Okay, and then one more. This one here is a little bit more with the radicals on there. And this is also why I'm stating that if you understand what the graphs look like, this shouldn't be like crazy. You're like, oh, a radical, no problem. I know it looks like half of a sideways parabola. And so, and that it's linear and recognizing it makes the math so much more doable if you recognize what these graphs actually look like. So here we have f of x and then g of x there. And so when you graph it, we know that you're going to have to find the intersection of those 2 points. And so here is one intersection and here's the other intersection. So we're going to go from 0 to 4. And so when you're doing this, we're going to integrate from 0 to 4 there. And so you're going to take this function, which is the one above, which is your f of x, and then you're going to do it with the one below on there. And so then you are just going to then calculate that. You do the integral information on there, and then you get your integral from 0 to 4. You combine the like terms there. This is what you end up getting. And then you take the antiderivative of it, and then you evaluate, and you get your answers to be 4/3. And I got this off of She Loves Math. And so, women do love math, and this is a very interesting problem here. And this is a typo right here. It's supposed to be x plus 1 and not x plus 2. So this one here was a typo. It's supposed to be a 1 there. is. You see that it's up there. And same thing on there. So that this is the math is correct there. Okay, very good. Thanks.